Right. Welcome everyone to well, I'm not going to call it midweek with Max. We're already stretching that when we do it on Tuesday and now it's Friday. So, welcome back to another episode of the Max show featuring John, Jeremy, Josh, and me. Um yeah, it's weird to do it on a Friday and it's not even at the right time. So, I can't call it midweek with Max even though it technically is.
We were uh,
Anyway,
we were talking about calling it almost end of week with Max, which you can pronounce Aom, but I guess that
yes.
didn't catch on with the rest of the team.
Well, welcome to Aon. And yeah, I'm Rick, and let's just kick it to Max because it's early and I'm rambling, and yeah, this is gonna be a good one.
Off
All
to a
right,
great
cool.
start.
Yeah, but off to an amazing start. Couldn't have gone better. Yeah, awesome. Well, appreciate everyone showing up at the rescheduled midweek, now late week, whatever it is, with Max. So glad we're able to still get something on the calendar. We're working on some travel plans, doing some team strategy meetings in person. So uh, working around all of that, but a lot of good progress. Working on some rollout plans for some of the new technologies we're working on the Hemi side, particularly around the ZK vaults for HBit VM in the Bitcoin tunnel, and how we're gonna some people we can partner with, and some ways that we can get people to try out and test that new system as soon as it's ready, and then start moving that towards production with some larger TVL providers, capital providers who are interested in using the system. So a lot of good stuff this week. As far as updates on the engineering side, I've been continuing to work on the Opreth migration and Oxygen integration and the whole ZK provability piece. That's coming along well. I've been doing some cleanup and work on the ZK market, ZK miner. John's been taking a look at some of the new ZK miner stuff that we're working on, some bug fixes, and just doing a general review of that code base, which I don't believe that's open source yet, but that's probably something we're going to be looking to open source relatively soon. We do have some other, let's see here. I think we can resolve that later in the show, but there's a couple of the ZK things that are either currently open source or will be open source pretty soon. So we'll announce that as those come out. Other than that, I've been also making some improvements on the MinerFi side, doing some bug fixes on the Continuum daemon and some continued testing there. And I think that's the majority of the updates. We are part of the in-person strategy session was putting together a incentivized testing plan for the ZK market, ZK miner system. So we're going to be rolling that out on testnet probably in the next 3 to 4 weeks with some initially small, but expanding over time depending on interest and how much valuable feedback we get from it. A testing plan for that for people to start playing around with, both primarily on the people running ZK miners for the market, because that's the easier thing for people to do, set up, and probably the most valuable feedback at this point. And then also a little later, probably some testing incentives for being on the ZK proof requester side, so actually submitting jobs to the market for your own bespoke ZK circuits. Other than that, since I've been sort of in and out this week, John, was there anything else on the engineering side you think was interesting? Anything you wanted to highlight?
No, I think, believe it or not, that largely covered it because, the continuum work and there's been a lot of progress on Dave, our open source backup tool, or not progress on it so much as we've confirmed that it works properly. And we expect a nice blog write-up about it soon in case people want to check that out, as it has potential, general blockchain backupping usage. So that's the other main fun thing that people were doing this week.
All right, cool. Well, with that, I'll give the usual quick updates for frequently asked questions. So VBK, no new updates on that, but as soon as we have something, we will share it, and that distribution is going to happen. And then on the VE Hemi rewards, we're writing up a new hippo for a new way that it's mostly the same as before, but there's a few changes to the way that we're going to be doing the distributions. And so there's going to be a new hippo for that, hopefully published early next week, along with the distribution itself. So we finally got final answers on some of the changes we wanted to make to that and got organized around that in our in-person meeting. And then I think that's pretty much everything. We're also shipping. We're finishing up internal testing of the opgeth hardening release, and so a version of that is deployed to a lot of our infrastructure at the moment. We're finishing up the mainnet deployment, and we should have a release of that publicly available for anyone running nodes sometime next week. So we will, as soon as that's ready, we'll announce that on Discord, so anyone who is running nodes can do that upgrade. It's not a time-sensitive upgrade, but it is a recommended upgrade that if you're running a node, you should do when you get the chance, once it's available. And yeah, I think that's pretty much all of the main things. So I will turn it over to Rick.
All right. I am going to bounce it to Jeremy in case there's any marketing updates. But then I'll take it back.
We do have some marketing updates, and I'm wearing a very bright orange shirt today, by the way. I just wanted you guys to know that. It's very Hemi themed. We have our Built on Hemi show today with Akash Patel from Vetro. If you want to learn more about what's going on with Vetro, how that thing works, what's it doing with Hemi, you're going to want to see my show today, okay? It's going to be a great show, and you're going to love it. Also, on the marketing side, we don't have a lot of major updates from this week, but I can let you know a little hint. We have a pretty decent-looking incentives program coming up with a new partner coming very soon, and I can give you more details on that announcement when we're ready to announce it. I don't want to ruin other surprises or anything like that. Quit peeking at your Christmas presents, okay? All right, so I can hand it back over to Rick now. Thanks, guys. Hope you have a wonderful day.
Jesus, how caffeinated are you?
I've only had the one cup. I'm only on the one cup, but it's hitting me strong. It's really good stuff. It's Colombian.
Yeah, but the question is, how big was that one cup? There are.
Seriously.
Oh, look, it's this cup. It's just this cup. I'm not even halfway through it. Look.
That's wild. Jesus.
I just got all that energy.
But before we get into questions, I just want to wish a very happy birthday to Yahoo's, one of our community moderators, who is actually working with our marketing team now. So happy birthday, bud.
And he's great, and we love him. Happy birthday.
Yeah, rock and roll. All right, so let's get
Rick,
into
you're not gonna sing to him? Come on.
No, I thought you. Why don't you, John? You got the pipes.
Nobody wants that.
All right, well, I guess we'll get into questions then, because John's refusing to sing for Yahoo's birthday. It's pretty shitty.
John, jeez.
Right. Alpha, of course. Alpha asks, what is Hemi's roadmap?
High level, the big items are the formerly MinerFi, now Fast Track, and the ZK settlement to Ethereum, and then after that, ZK vaults for the Bitcoin tunnel. So those are the two main giant engineering items that we're currently working on. Beyond that, there's, pretty much an infinite roadmap, and the prioritization of some stuff may change as market conditions change, interest in different types of protocols changes. But as far as what's on the list in no particular order, decentralized sequencing, decentralized publishing and batching, state republishing and batching that has to necessarily come after ZK proving for a couple reasons. Chain builder, so our L3 chain in a box system, and there's multiple different stages of that, from a MVP of a L3 that's essentially a Hemi clone on top of Hemi that can be customized a limited amount for different trade-offs between decentralization, security, speed, and cost. And then a larger multi-phase roadmap after that for potentially different consensus protocols, being able to being able to swap out architecturally the execution engine, so being able to run things other than an EVM or a customized EVM that does maybe AI-focused opcodes or something like that. And then eventually a shared sequencing, shared DA system that all of those L3s can optionally use to get A, sort of just make it easier for people to launch chains, but B, also provide a common ground of interoperability between the L3s and Hemi itself that's a little more tightly coupled than what you usually get with disparate L3s that are using different DA systems and different sequencing systems. So those are the large items. We got tons of other stuff we're working on. The ZK marketplace, ZK miner is sort of a adjunct isn't the right word, but a side component that is going to make ZK proving of the Hemi network a lot more economical and decentralized, and that could expand more broadly into. It's already designed this way, but it depends how we go to market and incentives, usability, developer documentation, stuff like that. That makes it easier for third-party protocols, either on the Hemi network or Hemi L3s or other blockchains, even unrelated to Hemi, that just need ZK proving, that they could plug into that marketplace and use that for any RISC-0, SP1, OpenVM, and in the future, Jolt and Zisk as those come into production. Anyone who needs ZK proofs for any circuit for any of those systems. We've also got some other things that we're working on with partner deployments. So I don't want to front run marketing and BD with some of the stuff they're working on, but we're working on getting some new interesting types of exchanges on the network. We're working on some things around Hemi Earn and partner protocols that would enable new yield sources for Hemi BTC as we come into this ZK Hemi BTC and the fast track, easier way of onboarding and offboarding Bitcoin onto the system, sort of a liquidity wrap around the large, slower moving ZK Vault system. So a lot of moving pieces, but current roadmap, ZK Miner, ZK Marketplace as sort of an adjunct supporting role to all of the Hemi Network ZK proving, which gives us Ethereum settlement, lets us finish up the HBIT VM piece for ZK Vaults for the Bitcoin tunnel. Fast Track, which is this liquidity wrapper around the HBIT VM ZK Vault system and provides an easier on-off boarding experience for Bitcoin for people with smaller amounts or who are frequently moving on and off the network for, say, doing arbitrage across other markets, things like that. And then longer term, decentralizing sequencer, decentralizing data publication to Ethereum for DA, and publication of state roots with corresponding ZK proofs to the Ethereum network. And then beyond that, chain builder. And while we're doing all that, third-party protocols and partners who do interesting stuff either on Hemi just as another EVM chain, or hopefully as we make some improvements to HVM, add more features, have some cool new stuff that developers can work with the HBIT VM ZK Vault system, some more HVM focused or Bitcoin specific things that you can only do on the Hemi network. So that's I think that's the roadmap in a nutshell. Not much has changed since a couple weeks ago, but that's what we're currently looking at.
All right. Let's see. What procedures and policies are in place to ensure Hemi's marketing posts are factual and correct?
We do have an internal review process, but it does need to be improved. We've been making some changes and there's been some churn on the marketing side. So it is something we're looking at improving.
All right. Oh, geez, holy shit, that's a lot of questions that came in. Let's see. We'll save that one because I have a feeling there's going to be a lot of discussion there. Is Hemi doing anything to bring new institution funds on the Hemi chain other than from a technical side?
Yes, I can't go into too many details, but we are talking with a lot of different entities and people who want to bring Bitcoin to the system once we have this ZK Vault system in place. So it's yes, something we're actively working on in parallel with building out the tech side of it, but can't go into too many details on that. Obviously, we don't want to announce something that either isn't going to happen or we don't know the timelines for. So short answer, yes, but can't go into many more details on that.
All right. This is a bit of a follow-up to that marketing question, I guess. Might be a bit redundant, but what the hell? It's in the list. Over the past 6 months, many of Hemi's social posts have been AI generated and contained poor quality images or mistakes about the features of Hemi. What is Hemi doing to improve this going forward?
Pretty much same answer as before. We've been making some changes on the marketing side. There's short answer, we're making changes. Things should be improving, and we've taken down some of the posts that didn't really make sense and that we caught that some people on the marketing, I don't even want to say people, but some parts of the marketing team and some procedures ended up creating some content that we weren't too happy with. So we've taken some of that down and we are improving the process going forward.
All right. Awesome Chameleon asks, why have wait, hold on. What the hell did he ask? Oh, there it is. Why have Hemi security programs stopped triaging or accepting reports?
We are still going through them. There's a huge backlog of AI submissions that make absolutely zero sense, but we still have to wade through and triage and try to figure out what they're even talking about. So it is. We're working through it, but I think every bug bounty program, not just in crypto, but the entire. You even look at Trend AI's ZDI program. They have, I think they're up to like a 6 to 8 week backlog now for triage, just because of all the ridiculous amount of AI stuff coming in.
Actually, I want to add to that, because it's not so. Not only are so we're not no longer accepting things. That's not. We are obviously behind in triage, like fuck, but so is everyone. And it's not just the projects that are behind in triage. So it's also the actual platforms that are doing bug bounty, because the platforms that run bug bounty program. So your Bug Crowd, your HackerOnes, your I can't think of any others right now, but there are others. They're behind because they're also drowning in this wave of AI crap. There's people who are using AI to do good security work, and that is awesome. And that is using a tool to, actually make the world more secure. But then there are people who are throwing AI at it, and for like the millionth time, sending us the same report that there's this horrible bug that you can see transactions on your blockchain. And
oh no.
yeah, you don't know how many times we've gotten some version of that. And look, no offense, but no shit, Sherlock. You can see transactions on a blockchain. It's a blockchain.
Yeah.
The whole fucking point of it, and we have to go through them, but that not only slows us down, but that slows Bug Crowd down. So we're us, Bug Crowd, literally the entire industry is doing the best it can. And the only thing we can ask is A, for your patience, and B, use AI to do bug reports. Like, use AI to find bugs that you wouldn't otherwise. Use them to format your reports better. Don't use them to report the same crap that you don't understand. Because if you do that, you're going to end up, you slow down everybody, and not just to us. Like, don't do it to other projects. Don't go and do it to report bugs to curl that aren't really bugs, because you're not making things better. You're also not going to get money from it. So you're burning your tokens just, to be a dick and to give everyone problems. So yes, we're behind. Everyone's behind. We're doing what we can. And we want to see good reports that use AI, and they're there. But, if you're using AI to do bug reports, make sure you understand what's going on. Don't send the same report that you can see transactions on a blockchain. Thank you.
It's like when you give
can.
everybody tools to do stuff, and then like everyone has a smartphone now, so everyone's a professional photographer. So now I got a bunch of blurred pictures of cheesecake everywhere. Nobody wants a bunch of blurred pictures of cheesecake, okay?
I mean, I'm kind of hungry. I would not. Yes, it is 10 a.m. for me, but I would not say no to cheesecake.
Hey, cheesecake's a wholesome breakfast, right? It's got all the stuff you need to build a good body.
It's got sugar, fat.
It's got all macros. I don't see what's wrong with it.
It has something crunchy in it. That's got to be a food group, right?
Yeah,
we'll accept that.
But yeah,
we'll accept graham cracker as its own food group moving forward.
Get your vegetables, your
like
meats, your oils, your graham crackers.
Your graham crackers, etc.
It's a staple in America.
But yes, that is
weren't the graham crackers the top of the pyramid or something like that?
No, you sprinkle them in the middle. They're in the bottom, because they make the crust, right?
No, but I mean the food pyramid. Like the graham crackers are at the way top, the peak.
Yeah.
The desserts.
Guys.
Yeah.
Guys, back to the blockchain show.
I'm sorry, Rick. It's Friday.
I know, but someone has to try to keep the trains on track. All right. Oh shit, this is gonna be a big one. Alpha asks, anything to say on the Bitcoin cold wallet hack? My theory is yes, they have a lot to say. So I'm just gonna shut the hell up.
No, that's a good one. So for anyone not familiar with what happened, and I'll put this in general terms so it applies, because there's been a couple of these similar patterns of vulnerabilities in the past, both with hardware wallets. There was one with the Android wallet one of the Android wallets way back in the day. There's been ones with other, wallet softwares, different versions of it. Fundamentally, it comes down to bad randomness. So again, keeping it high level, basically when you generate a private key, that private key that you're going to use for Bitcoin, whether it's a private key or a seed phrase that you can derive private keys from, it needs to be generated in a way that's random and nobody else can predict it. So computers are really bad at generating random numbers. In fact, they cannot generate random numbers in a true sense. Computers are deterministic machines. You give them inputs and a process for computing over those inputs. And unless they're broken, they're going to give you the same outputs every time. And that's why computers actually work and we find utility in them. But for something that's truly random, there's no way for a computer, a human can guess a random number. We're pretty bad at it. If you say, give me a number between 1 and 100, it's not going to be an even distribution of people who choose 1, 2, 3, all the way up to 100, right? People are going to cluster around certain numbers they like or easier numbers or something in the middle or whatever. But computers can't generate random numbers at all. All they can do is run procedural programs. And if a computer gives you a truly random number, it means it's actually broken. So in computing, you have a couple ways to get essentially random numbers that can't be predicted. So there's things you can do with, say, entropy from certain computer sensors, right? So, if you're on a Linux box, for example, your keystrokes and mouse movements and network traffic and the timing of TCP packets that get received by your network card and things like that can all be, some or all of those can be incorporated into a randomness pool, basically, in your machine that you can use for different things that require secure randomness. People who get really fancy with it will have, systems that, say, measure atomic decay. And so you can have a little bit of some radioactive substance in a device that can basically wraps a Geiger count around it and, for a particular time slice, sees how many, atomic decays could be detected, or looks at the timing between detected atomic decays, things like that, because those are truly random information from the outside world that a computer can take in and turn into ones and zeros and then use for secure randomness generation.
Atomic decay, remember, is one of the things that is truly, like, really random.
And we're not saying to be secure in Bitcoin, you need to strap your computer to a block of uranium, but don't do this at home. But if you want really good randomness, there's a couple ways, like random decay, that are, as far as we know, based on the laws of physics, we understand, truly actually random and unpredictable. On the flip side, you have really bad ways of generating stuff that looks random, but it's not actually random at all. So there's something called a PRNG, which is a pseudo-random number generator, and the word pseudo should generally scare you. There's ways to use PRNGs on top of good randomness to turn that good randomness into a stream of truly random data, but PRNG fundamentally is an algorithm that is deterministic over some input and gives you apparently random numbers. They're statistically well distributed, things like that. You can't, or you shouldn't be able to, detect any sort of bias in the output of a PRNG. But the algorithm is dependent. The algorithm is deterministic. So if you know what went into the algorithm, you can recompute it and figure out what comes out. So one of the things people do for randomness that does not need to be super secure, maybe it's randomness for a local video game you're playing or something. They'll use the system clock and they'll feed in the current Unix epoch or something into a PRNG, and it creates numbers that the user can't easily predict, and they seem random and they work for the game mechanics. But if you could make a bunch of money by predicting the random numbers that were generated in someone's game at a certain point in time, you could basically just repeat the process and say, well, their clock would have been at this timestamp when they were playing this game, and so they would have used this timestamp as an input to this PRNG and gotten this stream of random numbers out, and that means this in the context of the game. Therefore, we can predict, how their game experience was for this time slice that they were playing. Doesn't matter for a game. It does matter a lot when you're generating a private key for a crypto network. And so the cold card case in particular, essentially they had a way to generate quality random numbers on the hardware, but the software that they were using for managing the wallet, generating the private keys was basically they had like a dev mode sort of thing enabled that did not use the secure random number generator in the hardware. And I'm not sure whether that was based on, hardware sensors or exactly quite how they were doing it, but essentially they had a quality randomness source in the hardware, but they weren't using it in the software for a period of time. And so people who generated wallets or, private keys, seed phrases during that period of time were using a dev mode PRNG that's useful for testing, but not for actually generating secure randomness. And so basically, an attacker was able to predict how that dev mode software-based PRNG with deterministic inputs would have behaved at different times on different hardware devices that, again, we're not using the true hardware secure source of entropy. So that's what happened with Cold Card. And then as far as lessons learned, like things you can do where, if you buy a hardware wallet today and you plug it in, it is essentially a black box. You can go, a lot of them have open source software and firmware. You can look at how they work. You can expect it. But, do you really know that's what's being loaded on the hardware device? Do you know, even if you see, in the firmware that they're using a secure source of entropy that's embedded in the hardware device, and you can see they're using it, do you know how that piece of hardware actually works? And was that built correctly? And so one thing that you can do is you can combine entropy sources, and it depends on the hardware wallet and depends on how you use the wallet and what options you want for, say, recovery and things like that, for what software you can use. But there's ways where you don't have to trust the randomness of just the hardware wallet, however it's implemented, whether there's a software bug or not, whether there's an issue with the hardware implementation of the secure randomness source or not. You can add your own entropy in. So if people remember, if you're in crypto a long, long time ago, using, I forgot the name of it, but there was that site that let you create paper wallets. And one of the things that you would do on the site when you wanted to generate a key is you would move your mouse around in a box and it generate a bunch of entropy. And, no matter who is, obviously somebody who's like on your computer locally could see that and steal that, but they have to breach into your system. But nobody could deterministically say, okay, somebody who is using this site at this time to generate this, to generate a Bitcoin private key or whatever, would have had this input into the PRNG and generated these numbers, and thus this private key, and thus I can reproduce that on my system at a later point in time and steal the funds. And so, unless they could predict exactly how you're going to move your mouse and the timing, they couldn't predict the randomness. That's an outside source of entropy that's external to this deterministic software running on your computer. And you can do things like that with hardware wallets. It, again, depends on the brand, what features they support. But there's things like BIP39, which let you add essentially an extra pass key, if you will, on top of the seed phrase. So you have your base seed phrase that makes sure that, you have some randomness that you don't control as a human and you couldn't mess up. But as a human, you can also layer additional randomness that you generate yourself. It could be, your cat walking on your keyboard. Obviously, write it down, because if you lose it, that's part of your private key. You lose your funds. But you can add in that extra entropy. So even if somebody cracked the seed phrase generation algorithm and found it was using a bad form of randomness that they could reproduce later on, they couldn't reproduce the extra randomness you layered in on top of it. And so, again, depends on the hardware wallet, depends on how complex you want to get with this. And the more security you have, the more chance there is you'll do something wrong and not write the right part down, or lose this part of your private key that you added in yourself that isn't part of the standard thing. It doesn't fit on the 24 words that you usually write down for your ledger wallet or whatever. But there are ways that you can add in that extra entropy that you can get from another source. You can generate yourself as a human, and without, again, getting too deep into the weeds, there's things that you can do algorithmically on the random number generation and how you use random number side, where you can say, we can add anything, any source of randomness, even if it's low quality, and it can only essentially help the randomness. So, for example, say you have a really good entropy source, and then you have the human input something else that gets sort of not added literally as an addition, but added or mixed into the randomness. You can do it in a way where no matter how bad the randomness the human introduces, there's nothing, it can't harm the entropy. It can only help the entropy that you're pulling from for this random number generation. And so things like BIP39 use that sort of a process to basically allow you, it could be, and again, we're not suggesting you do this, but just for the sake of understanding how the system works, you could have a very simple thing that you add on to your seed phrases that's easy for you to remember. You're not going to forget it. And maybe someone could realistically predict it if they knew you or something. But the fact that you've added that in does not harm the security versus having not done that at all, and would protect you at least to some extent if there was a compromise in the random number generation of, say, the hardware wallet or something that you're using. The ideal case is you have, some very random, very unpredictable string of random characters and numbers and symbols that, you add on to the seed phrase using, again, like a BIP39 methodology, which a lot of hardware wallets support. And then that would let you have, as long as you don't lose that and, lose access to your funds, that would give you a very strong additional entropy source that you're adding in. So even if the entropy source for the hardware wallet gets compromised, you are still protected by that randomness you added. But even as a initial easier step, if you just added something that's still very memorable to you, but not easily predictable globally, that's still an extra layer of protection. And it can't, unless you forget it, it can't harm you adding in that extra entropy.
And
that was longer than I should have gone on that, but
that's right, because I have more to add to it. So one thing that's important is that, Max, you said a bunch of times about adding entropy. And I think that's important that people recognize the difference between adding entropy and coming up with a random number. The worst thing you could do. So entropy and a random number are not the same thing. You're adding when you add entropy, you're adding entropy into whatever seeds the pseudo-random number generator. Trying to come up, that can be done in safe ways. Trying to come up with a random number will not be safe. So, like, there's this temptation, like, you could say, well, look, this hardware wallet didn't do random numbers, right? Why don't I just randomly come up with, the seed phrase myself? Why don't I come up with the, seed phrase myself or the random thing? And that's, if you don't think about that too closely, that sounds like a good idea. Like, I can randomly, look around my desk and see, like phone, rock, start picking words that I think are in the seed phrase. That will always go bad. You cannot, on your own, non-mathematically come up with a random number and expect it to be, actually a high entropy, hard to guess thing. Don't do that. You will fuck up. Like 100%. That is a bad thing to do. Adding entropy is different. That is something that can be done if you do it appropriately, and you have to know what you're doing and read the docs and talk to people who know things. That can be done safely. Just coming up with a seed phrase yourself will be a low quality guessable one. Coming up with a random number yourself, 12, is not, it's not going to work. But there is another even lower tech thing you can do to lower your risk. So Cold Card had a bad random number generator, right? And that's unfortunate, and you feel bad for anyone who uses them, and you feel bad for the team because sometimes having a dev mode with a predictable random number makes sense for debugging or for development. And I mean, random's hard. Debian screwed it up too when their random number was 4 for a while. I mean, that was pretty bad. But one thing that you can do that improve, always a thing that makes you safer is to spread your risk out. So I have a ledger. Ledgers are great. I like them. I mean, they break a lot, but they're still, and the key buttons stop working, but they've had a pretty good track record in terms of their device security. Does that mean I should trust every penny I own on a ledger? Probably not. Maybe you should, if you were to split, so like take a cold card user. If they had some of their funds on a cold card, some on a ledger, some on a Trezor, they've now, to lose everything would require all 3 devices be compromised. That is a lot less likely. Anything that spreads your risk out. It's the same reason monoculture, I think my bell, the same reason that monoculture and Microsoft being everything was such a bad idea. You need to spread your risk out. There's a reason I have Linux boxes and OpenBSD boxes and Macs. You're spreading things out. You're, guaranteeing that one bug is much less likely to be the fatal to you.
And to add on to that too, there's I'm not sure the right analogy for it, but there's, like John said, you can always do, multi-sig where you have, 3 different hardware devices and you need either all 3 of them or 2 of 3 of them or something. There is also this thing that in the real world, in the ideal security environment, you're like, okay, I'm going to generate a brand new seed phrase with every single hardware device out there, and I'm going to put them into an N of N multi-sig, and I'm going to add entropy to each of them that support bit 39, and right. And then, but there's also brittleness that you accumulate from a real world perspective of like, what if you lose one of those seed phrases? What if one of the hardware devices used a non-standard seed phrase and you can't buy it anymore because it's been discontinued, and you still have the seed phrase, but you don't even know the algorithm they used, and like, are you going to spend a week hunting that down, reproducing that in software, to whatever, right? That's a bit of an extreme case, but there's, the more security you add with a lot of these things, the more brittle it becomes. If you just do it naively of, okay, N of N multi-sig or whatever. But in practice, you can do a 2 of 3, which actually gives you some resilience against, obviously a bug in the actual random number generator for one of the hardware devices, but it gives you resilience against you making a mistake and losing, say, a seed phrase or something like that. Because, okay, well, if you have 3 seed phrases and 3 different physical locations and you only need 2 out of 3, that's actually better resiliency and better security at the cost of being more complicated to manage and deal with and understand, and set up. But it gives you more resiliency, both against a security issue, but also against you making a mistake and like losing access or something to a phrase. So there's smart ways to do it. There's things you can do that seem super secure, but they're so secure that you yourself lock yourself out. So you got to be careful and balance them. There's also things, and this is one of the things I think in crypto that's underdeveloped, as far as there's people doing this, and there's ways to do it, and there's protocols and products. I'm not going to recommend any particular one, but the idea of social recovery. So being able to say, it's not just about, in like the old days of crypto, it used to be, and it kind of still is to some extent on Bitcoin, but there's even ways to do this on Bitcoin. But it used to, the model used to be, I generate a private key, I have that private key, and it lets me access this account. And if I lose that, I lose access. If someone steals it, they get access, right? It was very one-to-one. A key gives you access to an account that has value, and you can either lose it or have it compromised. And then the next stage was, okay, well, what if you had multiple of those? Somebody would have to compromise, 2 of 3 or 3 of 5 or whatever you have in your own multi-sig setup that you did yourself. And you also have that resiliency against losing 1 or 2 of them because you have that redundancy built into the system for surviving failure of a couple hardware devices, losing a couple keys, whatever. Then the third rung of that, which this is the part I think is underexplored, is more configurable, where it's not just number of keys in a multi-sig, but it's programmatic rules around control of funds in certain scenarios. And so you'll hear terms like social recovery thrown around. There's things you can do to say, if I don't move the funds for 3 years, then this additional set of signers comprised of, close friends and family or a company that provides this as a service or whatever can go in and get access to the fund. So if I'm, I have and it's easier to do on Ethereum because you have, programmability on an EVM network, but you can still do this to some extent with Bitcoin with the way that you set up, complicated scripts, complicated locking scripts that control how your money can flow at what point in time, by who, and in what ways. But you can set up things where you say, if I lose the key, I can't access the funds at all. But if I don't touch the funds for 2 years, then this, 2 of 3 of these people who are close friends or a company that provides this as a service or whatever, they can go in and recover the funds. So they can't touch them if I'm actively proving I have access to the wallet by doing a transaction at least once every 6 months or a year or 2 years or whatever. But if I do truly lose access, they will be able to recover them at some point. So there's things like that you can also, and again, depends what chain you're using, what assets you're using, how complicated of a setup you're comfortable with. But there's things like that you can also do that will let you, that doesn't protect you against somebody guessing your seed phrase. So if your cold card wallet was your one of one for sign regular transactions, that doesn't secure you. But if you want to do these more complicated setups with multi-sig, where there's more risk of you maybe doing something wrong or losing the seed phrases or not being able to restore one to a hardware device that you can't get anymore because they use some non-standard something or another, whatever it may be. There's other mechanisms like that you can do to also increase the resilience of the system beyond just who controls what number of what keys in what system, but also what, time-based or event-based triggers will let somebody else who normally wouldn't have access to the funds help you regain access to the funds. So I think we spent like almost 30 minutes talking about wallet security and ways to build resilient wallets. And, you could spend a year coming up with a perfect system, right? And there's no ideal solution for every person based on what amount of funds, what kind of risk, how quickly they need to get access to the funds. It's just as bad of a security incident if, say, you had a lending position on a market that you couldn't get to and manage in the event, quickly enough to, say, avoid a liquidation, as if somebody were to steal your keys and just steal that lending position from you, right? So there's always a balance depending on what you're doing, but there are a lot of ways where even if you want, to use one hardware wallet and, keep everything simple, there's ways to add entropy to it. If you're okay with a more complicated setup, there's a way to use multiple hardware wallets and spread the risk around like John was talking about. If that sort of a system scares you because it's complicated, and it still adds more complication, but there are ways to balance that risk as well with things like social recovery, time-based recovery. So there's a lot of options in the world that people aren't aware of in a lot of cases because they hear you get a hardware wallet, it's secure, and that's not the full answer.
Let's see. The rules for the Hemi Arcade Game Contest mention permission to be included in any future Here game season. What are these and who owns it? Do I keep ownership of my game?
Let's see. So I'm sorry. Let me. I just got a Slack message I was looking at. The rules for Hemi Arcade game, permission to be included in any future Here game sessions. So you still own your game, but you're basically licensing the game to be used as part of a future Here game season, if that makes sense.
Also, remember,
the
games have to be the games have to be open source. So you can't go and throw something closed source up there and expect us to look at it.
That means anyone can use your game after you submit it. Because it's open source, or at least under the auspices of the open source license.
Yes.
Yeah. So
essentially, yeah. It's a little more complicated because you can license it. You could license it so that only you or Here Games are allowed to use it, right? So there's some stuff you can do on the licensing side, but fundamentally, it's kind of like we license almost all of our open source stuff as either MIT if it's new or with whatever license we need to use if we're building on somebody else's software that's licensed with, some other OSS license. But, if you want to, for your game, you could specify something like, it can only be used, it can only be, launched or hosted or whatever by me or, the Here game, a future Here game season or something, if you wanted to do that. But being open source, that wouldn't physically prevent somebody from using it, just like you can open source software but license it and say nobody can use this in a commercial product. It doesn't physically stop them, but legally it stops them. So you do have some options, some flexibility with the license. But
all submissions to the arcade game contest need to be open sourced with their sources published on either GitHub or GitLab. And we require that all submissions are licensed under either the MIT license or the ISC license, which are both permissive and grant anyone permission to use, distribute, or modify your code. So we only included that rule just so that people are aware that if you do participate, it's going to be open sourced and licensed permissively. So it already gives anyone permission to go and run your game. But it's so that we can include it in Here Games at a later time.
Right. I'm sorry, I forgot we specified a license requirement. So yeah, disregard what I said. It needs to be permissively licensed. So
All right. The game must be on chain. That means how about security?
not quite sure what you're asking. So essentially, it needs to have some on-chain component. So that can be, it could be as simple as the user submits their score on chain, right? Or it could be as complicated as the entire game engine's running on chain, and every time you do a game interaction, you're interacting with a smart contract that validates your game move or whatever, updates some global or semi-global game state, and then that affects how other players interacting with the game can interact with it. It could be that you're using on-chain an ERC20 for an in-game currency, or some NFT thing for exclusive items in the game. So it's very open as to how you want to interpret that, but it must have some on-chain component. There must be something that causes a user at some point playing the game to do an on-chain transaction. And if you want to compete for the category of the most I forget exactly what we called it, but I call it like chain native or most chain centric design, those would need more of those mechanics that do interesting things on chain. So it's not just about the number of transactions of, for no good reason, you make users send a transaction every 8 seconds when they're playing the game, but there being some interesting benefit that having some part of the game on chain gives you, whether that's security of the game mechanics themselves. So if it was a chess game, you can enforce the rules of chess with a smart contract, and you can use that to enforce, a chess clock and things about turns and track scores and run, secure tournaments. Obviously, somebody could use, AI or chess engine or something too on their side to choose their moves, but you're actually enforcing game rules on chain in a, permissionless, auditable, reviewable, verifiable way. It could be something that does something interesting with game economics, like I said, ERC20 or an ERC 721 or some other variant of NFTs that gives value to the game because you have this exclusive on-chain asset that you can trade, that you can publicly, view, verify. People could extend it maybe and use it in other games that are, build on what you're building. It could be something cool with ZK proofs or even fully homomorphic encryption of some way that you have some game where some data needs to stay private, but certain parts need to be selectively disclosed or proven to be in a certain state for a certain reason. And, at various points in the game, you want to reveal or prove certain things about a local player's game state without revealing everything. That could be a cool way to use ZK proofs or some other exotic cryptography and have that validated on chain in a way that, a fully open, public, kind of traditional smart contract game engine wouldn't be able to do. So it's you can be very creative. We're looking for cool, neat, fun ideas of how to use blockchain technology to make a game actually better. But just to qualify for the competition for most fun, most unique game, just has to have some on-chain component, something that users do an on-chain transaction that's related to the game. It doesn't have to be complicated, or that part of it doesn't have to be particularly creative unless you want to compete in that specific category.
All right. Alpha asks, Rick, have you seen the open source Idle RPG game? Seen it? Yes. It looks cool. Played it? No, because we're doing that on Thursday.
I may have played a little bit of it. It was fun.
Oh, well. Any other notes or spoilers?
Yeah, why not?
You can go look yourself. It was really fun. I think he's still working on it. I pointed out a minor little issue, but it's looking good.
Sweet. Well, we hope to see a lot more submissions come in. Yeah, that brings us to the point. The Hemi Arcade Game Competition is still up and running. We will have an office hours next Wednesday at 11 EDT. Also, regular Midweek with Max. Back to Midweek, even though we're still, that's that's not 100% accurate, but Midweek with Max will return to its normal time frame, which is 11 a.m. next Tuesday, and that's in EDT. And you can apply for the builder role in the Hemi Discord, also the beta tester role. And yeah, contest is running till next Thursday, where we will have a live judging session / happy hour. So we will be drinking and playing your video games, and that sounds like the best work day ever. I'm very excited about this. Um, let's see. Well, we're back to Alpha. Alpha asks, when will this memory shortage end?
No idea. There's I by no means am an expert. I'm following it as just somebody who has to pay more for GPUs to test a ZK miner. But there are some Chinese memory manufacturers that are coming online, which may help with some of the supply issue. So far, we haven't really seen it affect that much of the market, to my knowledge. But yeah, given where AI is, where it's going, it could be the kind of thing where there's an AI bubble pop, and then all of a sudden there's a glut of new and used memory on the market. And but the other thing too is, even if a lot of it's not just memory as like a fungible commodity. It's like oil's not even fungible, because you have I don't know, sweet crude, and you have different like types of oil that are easier or harder to refine, and need different types of refineries and whatever. But something like oil is kind of a commodity where, in general, oil's kind of oil, and maybe some of it's a little more expensive to refine and whatever, but it kind of all boils up into one global spot market for the most part. Again, not a markets guy, but memory is less like that, because you have fabrication facilities that can build memory, but they can build different types. And so it's saying like, you can either choose to configure your car factory to build, giant trucks, like semi trucks, or you can configure it to build, tiny 2-seater cars, or you can build sedans, or you can build vans or whatever. But retooling a factory, there's time and there's a cost to doing it. And a lot of these, to extend the analogy, a lot of these memory fabs have mostly retooled over to the type of memory that you need for AI for GPUs, which largely is HBM memory. And there's even, versions of HBM, right? You can't use HBM4 on a GPU that's built to use HBM3 and vice versa. And all of the HBM set, none of that really works in consumer GPUs. And there's some, you can build chips that could potentially use both, but that's more cost in the design and validation testing phase of the chips. And I'm not a chip engineer, but just at a high level, you have this sort of non-fungibility of memory and memory production. And so even if the AI bubble blew up tomorrow and there's tons of data centers selling a bunch of excess GPUs that people aren't renting, and there's very little demand for the type of memory that you need for data center GPU compute, well, it's going to take time for those memory fabs to retool back to consumer DRAM chips. And that supply, it's not like it's going to just turn around and all of a sudden you go on eBay and you buy a bunch of cheap memory or cheap GPUs of memory, because those are specialized AI specific GPUs. And so if you want to rack a bunch of NVIDIA DGX boxes in your garage, great. Those might be cheap on eBay if there was a bubble pop or something. Or if you're on the memory market, like actually buying memory to put on a PCB and connect to a chip and use as a finished product, you might be able to get a bunch of cheap HBM memory theoretically, but your laptop can't use that, your desktop computer can't use that. The GPU that's bundled with HBM memory is a GPU that's not even built to do display output. And so there's not just AI bubble pops, memory goes back to normal. There's a supply chain issue, and then there's a fungibility of existing inventory issue with memory, that it doesn't just okay, now we can buy all the memory we want. Well, what kind of memory? Does it work with your system? Or a finished product that has a bunch of VRAM in it, is it something that you can use? Can you play a video game on it? No. Could you do AI inference? Yes, but it also needs a special SXM connector module that connects to the special baseboard that runs in the server that consumes 8,000 watts and would destroy your hearing in 2 hours of it sitting next to you in your room, right? So there's even regardless of what happens with AI and whether there is a bubble, whether it pops, when it pops, there's still going to be a giant sort of afterglow of effects and memory shortages. So not a market analyst, not a chip engineer, but that's my understanding of the space.
I'm glad you answered that question. I was just going to guess. I was going to go,
I mean, mine's a
I don't
guess
know.
too, but I guess
Yeah.
I've listened to a couple YouTube videos.
I was just going to say, I don't know, next Tuesday, let's say.
Tuesday, memory's getting back to normal.
Tuesday, memory
promise.
returns to normal. That's my uneducated guess on the subject.
Everybody's
Max,
rushing to
Before we have
Polymarket.
buy the memory so we can play the games on Thursday. That's perfect timing.
Exactly. Perfect. Max, you have a hard stop at 11, correct?
I can run probably like 5 minutes long, but a soft hard stop, I guess. Yeah.
All right. We'll shoot for one more, just because it's also game related. I have an idea, but I'm not sure how to implement it. I'm building an idle RPG game where every game tick, such as each attack or action, would require an on-chain transaction. On an EVM chain, that would mean users need to sign and pay for a transaction every second or so, which seems impractical and expensive. What's the best architecture for handling this type of real-time gameplay while still keeping meaningful actions or assets on chain?
It's a good question. So it depends on the exact game design. So there, if you think of something like a MMORPG, right? Like I played RuneScape back in middle school, so I'm going to use that as an example. The game clock, even for like that, now at this point, 20, 30-year-old game, it would do game state updates. I don't know, something like 2, 3, 4, 5 times a second, which is faster than what you normally get from even a extremely throughput optimized blockchain that sacrifices decentralization for just being able to produce blocks as fast as possible from like a centralized sequencer. So there's the speed of inclusion. Then there's also, you have to think about just because you can have blocks, say, on a specialized stepping back, there's a couple different solutions. So you could design like a custom game engine focused chain. You could try to use a specific chain that has a really fast block time. But even with those, you still have the mechanics of like mempool inclusion. So just because users sign a transaction every 200 milliseconds and there's a block every 200 milliseconds, doesn't mean that they'd necessarily get into the next block because they might be outbid. There might be a propagation delay in their transaction to the sequencer. At the speeds that you're talking about for gaming, you actually have to contend with the physical speed of light through fiber optic cables. So even if users are all on fiber and you have a centralized sequencer that can process 1,000 transactions a second, somebody who is 250 milliseconds of network latency away from the server can never get a transaction to the very next block. It just won't physically move across the earth fast enough. And so for the most part, and like if you look at, not a game designer, but if you look at like how quote unquote real-time games work, where say like a first-person shooter or something, they actually have to batch people together in lobbies based on their geographic location because they need people who are all can communicate with the server fast enough that it feels like a real-time experience. And with a blockchain, you could theoretically you could have like regional chains or something. You have the northwestern United States blockchain, and everyone's low enough latency to that sequencer that whatever. But more practically for blockchain games, probably you can do a mix of things. So you could build sort of like if you want to get like into cool, interesting blockchain engineering world, you could build things like state channels. And again, it depends on the format of the game. Is it a lot of players together in one room who can all, one virtual, not like spatial room in the game necessarily, but one, common state machine that they're updating as part of the game? Could you put them all in a state channel sort of off-chain system where there's some, leader who chooses the ordering of transactions, and you have a way to make them, say, non-biased in some certain way, whether that's how you shuffle and choose a validator, or whether that's with certain sort of, you can have, and this kind of gets back to the like DAG designs of blockchains. Could you have a thing where everyone on the network constructs their view of the order of transactions receiving the updates to the state machines. You have some reconciliation process. Theoretically, maybe a solution like that could work. But for a lot of game designs, that's kind of solving the wrong problem. There might be a lot of things that can happen off chain and then can be proven in batches on chain. So if you take something simple like, a 2-player game, that could be a very simple state channel between them, and they could play, 100 rounds of chess or whatever in the state channel. And then if, say, there was the winner gets $1 or something, you could prove all of that and settle that on chain, but the on-chain component, the latency doesn't really matter, because they can play the game in this offline state channel between them in a peer-to-peer fashion, and then later prove, every user signs their moves, but they're not submitting those on chain. They're just signing them. So collectively, they're building this verifiable, history of game interactions that, are all valid state transitions within the game engine rules, but can then settle back on chain. Or you could do, if you're trying to do something where there's, say, it's more like my example of, an MMORPG where there's a lot of players in a world and you're not sure which ones are going to interact with which other ones. And when they do stuff, you have to update global state. You could still do some sort of like off-chain temporary chain or something like that, where you do still have latency they have to worry about for, how fast can players send packets to the server. So that sort of sets a minimum, refresh threshold for your game engine. But you don't have to worry as much about things like, mempool contention or whatever, because you could design the blocks of this sort of, off-chain temporary network to always have, one slot for each player or something like that. So there's no mempool dynamics to contend with. There's no outbidding. There's no, censorship, assuming you have some good, leadership election system. So it depends what you're building. There's a lot of different ways to solve it. You're not going to build, Call of Duty or something with fully, on-chain transactions for every interaction you make with the game engine. But for a lot of designs, there's smart ways that you can either, collect state provably offline or off-chain at least, and then prove it back on-chain at some point where it makes sense, where latency isn't a big deal. Or, for certain games, maybe if you are doing a MMORPG, there's stuff that's, local to the player that they can do very rapidly, like, farming some resource or having some battle or whatever, but then you can sort of summarize that state and then prove it as a less frequent global state update that you can send back to the engine. So
also, there's one other way you can look at it that I'm thinking about. Like all of this, like people ask things like, how do I do this normal game mechanic and transplant it onto a blockchain? But that's not necessarily the right way to go. Think about the way games were designed for, much of the history of games. There were hardware limits, and you built games around that. So, like if you go and play one of the older Final Fantasy games, you can't save all the time. Saving's not instant because of various hardware limits. So you have set places where you can use a tent and save. So they've built a game mechanic around the limit, rather than trying to see how do I fit my pre-existing game mechanic into the limit. Or you had games like, say, Mega Man 2, when they added a password, where it was just a grid of dots in a fucking grid. But, you were taking advantage of the fact that you had set states that you might want to produce a password for, rather than actually saving something, because you didn't have a battery in the game cartridge, unlike, say, Legend of Zelda. So maybe you should be thinking of it that way, where you think, okay, I have a blockchain with this capacity. What game mechanic can I do to fit that? And, some of the best games that were ever made were built on very limited things. Take something like Tetris. There was, you didn't have, a billion frames per second and crazy graphics processing. You had simple things and, a very, talented developer thought of a way, hey, what is a cool mechanic I can do with what I have? So with blockchain, think about some of that. Think about what mechanics can I make that work with the tech that I have, rather than how do I fit my old shit into the new shit?
yeah, that's a good point. There's just to give kind of a quick, some game mechanics that are easy to do on chain and there's like real value in doing them, but then they could be integrated into another game or into like a game style that, could run faster than the block update time for a lot of things. Anything like in-game economy, that's an easy one, because a user can play a game for a long period of time and not really make any important, global state updates everyone else needs to know about. But when they want to, buy or sell an item from another player, that can happen on chain and having, a few seconds or, in Hemi's case, 12 seconds for that execution, not necessarily a big deal or, changes the way people interact with the game. Anything related to, say, identity. So if you want to have, each player needs to buy, one of our game tokens. So we fund development by selling a game token, and you need to have a game token to play the game. That's, it's more of like game DRM, if you will. But that's a very easy thing to do on chain because you can have a token that somebody can buy from a smart contract. They can prove that they have the token, and then that allows you to serve the game to them. Hopefully there's other things on chain they're doing that justified. Otherwise, someone could just take the game and launch it without the token guard on the UI or whatever. But also anything that's related to global, anything like a leaderboard or these sort of long-lived global state updates. If you have a way to prove a user got a certain score in a game, and we can talk about that more on Thursday or Wednesday. Sorry, if people are designing something that you need a ZK proof or something that a user did a certain thing in a game in a certain way and followed protocol rules and whatever. But being able to prove those on chain and say, here's a proof that a user scored 24,000 points. Okay, that updates a leaderboard. There can be in-game, maybe a weekly reward or something that's based on that, but that's not very latency sensitive. So there's a lot of things that are infrequent, not latency sensitive, in-game economies, leaderboards, player registration, player identity, anything around, checking simple rules of a game after the fact. So I think the example I gave a few weeks ago was Battleship. You have some private state, and as players interact, part of that private state is selectively revealed in certain ways. That's the kind of thing that you could do completely offline, but then later, prove with something like a ZK proof that, or just, replay all the game steps. But that's the kind of thing that you could use a ZK proof to say, okay, players played this game Battleship for 10 minutes. They played it in this peer-to-peer fashion where they're exchanging signed messages about their plays in the game over that period of time. But then at the very end of that, we collapse that state, post it on chain to decide the winner, and release the dollar that the players bet on it or whatever to the right player. And that part takes 12 seconds. It doesn't matter because the entire game experience was this off-chain state channel, or it doesn't even have to be that fancy. It could just be a peer-to-peer network where you're exchanging messages where the nonce increases. That's basically a poor man's state channel, and then you collapse it back on chain in some interesting way. So there's, like John said, a lot of creative game design is working around the limitations of the hardware, which in this case includes the hardware of a blockchain and the economics of blockchain interaction. So one angle is how do we engineer this like really complex, advanced, specialized system that serves this particular purpose, which is like saying, I want to build a 3D game. Let's build a GPU company so that we have GPUs so we can play a 3D game. Or you can say, let's build a 2D game with these known hardware limitations, this block time, this cost, these mempool interactions. What's a cool mechanic we can make that fits into that existing mold?
Right. Let's see. Oh, we are 10 minutes over. So yeah, we should wrap it up here. Geez,
I did see
have,
one question. Somebody was asking about the bug bounty program. They said they weren't able to submit because the program was temporarily paused. If you have a important submission and you're not able to submit it, you can submit it to secops@hemi.xyz. Security at hemi.xyz. If it's, we prefer those submissions be like things you're really sure about and high quality. But that is an alternate channel you can submit stuff through if for whatever reason you can't submit through the bug bounty program. Normally we would direct you to the bug bounty program, but if it's paused due to triage backlog or something like that, that is an alternate way. If you do have a important finding that you're sure about, that's a place you can submit it.
all right. with that, we will bring End of the Week with Max to a close, and you can join us again Tuesday at 11 EDT for the regular session of Midweek with Max, which will be followed by a Rumble session in the Here server as always. I don't know if that's happening today, because it's not Tuesday. So yeah, just forget I said that. But anyway, you can also join us on Wednesday for engineering office hours, where we can get in some final game questions. Don't forget our happy hour on Thursday at 4 p.m. EDT, where we will be playing your games live and drinking. Oh, and Alex said it's poker in the Here server, but it's already over. So uh, thanks, I guess.
Catch you
Sorry
next
to get
week.
people's hopes up. Yeah, sorry to get people's hopes up momentarily and then crush them. But and also, Jeremy, did you want to plug Built on Hemi one more time?
I always want to plug Built on Hemi. Come to Built on Hemi. It's going to be airing today at 12 p.m. 12 a.m. No, 12 p.m. Yeah, geez. 12 p.m. Pacific time, and look forward to seeing you there. Need more coffee.
Yeah, I was gonna say I feel like the caffeine rapidly
No,
ran
it
out.
just wears off. It like dissipates like helium right out of the atmosphere. It's just gone. And once it's gone, helium, it never comes back. So
It looks like this show took a lot out of you. Like you started, you were all buttoned up, had a hat on, and now you're like out of coffee and just really going through it, bud. Jesus.
No, I
To
got
be
some
fair, Rick, you had to
news.
listen to 30 minutes about random number generation, entropy mixing, social recovery. Like that's
Apparently,
that's an acceptable response, Jeremy. Hat comes off.
It's
so
early,
join us on
it's
Tuesday for another episode of Max Breaks Jeremy, and we will continue to go from there. So
Doesn't break Jeremy,
yeah,
just wears him down with the war of attrition.
yeah.
you're snoring. Just mute me, like
Oh shit. All right. So yeah. Anyway, thank you to everyone who tuned in. We uh, we're thrilled. So many folks joined us on a Friday. We'll be back to normal next week. And yeah, thank you to our community moderators, and again, a very special happy birthday to Yahoos. So go to the Hemi Discord server, wish them a happy birthday. Sing to them if you want. I don't give a shit. We have voice channels, so
You can do that.
whatever you want to do. But anyway, yeah, I'm gonna shut the hell up now. Let's kick it back to the rest of the team if anyone has outros. Otherwise, we will see you at Built on Hemi at 12 p.m. Pacific, and also we'll see you next week for 3 different events. Jesus, there's gonna be a lot of us next week. All right, that's it for me.
All right, awesome. We're already 14 minutes over, so I'll keep it quick. I appreciate everyone coming out to the rescheduled midweek now, end of week with Max. We'll be back to our normal scheduled programming next week, as Rick said. And stay tuned. We finally got any of the remaining things for the VE Hemi distribution figured out, so that will be coming out sometime next week, and we'll announce that when it does. There will also be a Hippo write-up for it for some of the minor changes we're making to the system, so stay tuned for that as well. And we will see everyone next week for Midweek with Max, Engineering Office Hours, and the gaming happy hour live session on Thursday. So a lot of stuff happening next week.